me see if the transcription have started. Okay. So the address resolution protocol is a protocol that will resolve an IP address into a MAC address. So to send a frame, an Ethernet frame or a Wi-Fi frame, for example, I need the MAC address of the destination. The way that I will get the MAC address of the destination is through the address resolution protocol. So what are the two primary goals of the address resolution protocol? Is first to resolve an IP address into a MAC address and to maintain what we would call the ARP cache. So when we send a frame in the same local area network, for example, let's say that the computer A here need to send a packet to the server that is here. So the computer A normally knows the IP address of the server, but he also needs the MAC address. He doesn't have the MAC address because, as you know, in the packet in layer 3, as source IP address, we will have the IP address of A. As destination IP address, we will have the IP address of the server. As source MAC address, I am A, I will put my MAC address, but I need the MAC address of the server. So I will have it through the ARP protocol. Now, if you look at a remote communication, let's say that A needs to communicate with the server. It needs to send a packet to the server. So we will have a first hop, a second hop, and a third hop. So in the first hop that will be sent by A, in the 3 hops, the IP address are not going to change. The source IP address will be the IP address of A, which is 192.168.1.110. And the destination IP address is going to be the IP address of the server, which is 172.16.1.99. They belong to different networks. Now, in the first hop, as we know, the destination MAC address will be the MAC address of the router in this interface. So A needs to get the MAC address of the router in this interface. And the way that A will get this MAC address is through the ARP protocol. Because remember that at the level of layer 2, we will have as destination MAC address, the MAC address of the router in this interface, and as source MAC address, the MAC address of A will go there. In the second hop, what will change also is the MAC. So the destination MAC address will be the MAC address of R2 in this interface, and the source MAC address will be the MAC address of R1 in this interface. And in the last hop, what is going to change is the MAC address. So the destination MAC address is going to be the MAC address of the server, and the source MAC address will be the MAC address of R2 in this interface. So, of course, let's see the example of the third hop. R2 needs the MAC address of the server. So if R2 don't have the MAC address of the server, R2 will get the MAC address of the server through the address resolution protocol, the ARP protocol. So, as I was telling you, the two basic functions of the ARP protocol is that resolve an IP address into a MAC address and maintain what we call the ARP cache or the ARP table, which is a mapping between an IP address and a MAC address. So many times when we show an ARP table, we will show 2 columns, but in fact it has more than 2 columns because every time that I put an entry in the MAC address table, it has a time to live. If this entry is not refreshed, it will disappear when the time to live is exceeded. Okay, so let's see, for example, H1 wants to communicate with H4. So H1 will need the MAC address of H4. Let's say that H1 doesn't have the MAC address in its ARP cache. When I have a MAC address, I store it in a table that is called the ARP cache for some time, for example, 2 minutes. So I store it there. So let's say that I do need the MAC address associated with 192.168.1.7, and it is not in my ARP cache. So what we'll do H1, it will send an ARP request. So the ARP request is a broadcast, which means that H1 will send it, and H2 will receive a copy, H4 will receive a copy, and H3 will receive a copy. And an ARP request will say, if your IP address is 192.168.1.7, please send me back your MAC address. So H2 will look at the question. And the question is, if your IP address is 192.168.1.7, please send me your MAC address back. So H2 will say, oh, this question is not for me because this IP address is not mine. So H2 will drop the ARP request and not answer with an ARP reply. H3 will do the same thing because the question is, if you have the IP address 192.168.1.7, please send me your MAC address back. So H3 will say, this is not my IP address, I don't have to answer this question. Now H4 will see that the question is for it, because it do have this IP address 192.168.1.7. So H4 will send back an ARP reply. And what you need to know, an ARP reply is a unicast, it's not a broadcast. So the ARP request will be a broadcast, but the ARP reply will be a unicast. And the ARP reply will send to H1 the MAC address associated with 192.168.1.7. So what they say here is that if it's a local communication, I should resolve. If I don't have it, I don't have the MAC address in my ARP cache, I need to find it through the ARP protocol. Now, if the destination is in a different network, my routing table will tell me who is the next hop. So I need to send it to the next hop. So what I'm going to resolve through ARP is not the IP address of the destination to a MAC address. What I'm going to resolve is the IP address of the next hop to a MAC address, because I need to send it first to the next hop so it can go toward its destination, doing hops, no? That will be the first hop, and then there will be other hops. Okay, so this is the PDU, the protocol data unit of an ARP request or ARP reply. They use the same PDU. We are going to see them field by field. So the first thing that you need to remember is that an ARP request is a broadcast, while an ARP reply is a unicast. Now, at the level of Ethernet, the Ether type, to specify that Ethernet is carrying a payload that is an ARP PDU, the Ether type have to be 0806. So when you have at the level of the Ether type 0806, it means that the Ethernet frame, the payload of the Ethernet frame is an ARP PDU. It can be an ARP request or it can be an ARP reply. So here we have several fields, and we are going to see each field. So the first field is 2 byte long, which means 16-bit long. And this field is called hardware type. It's identify what is the technology that I'm using in layer 2. So Ethernet, we will be using Ethernet, is identified by 0001. This is hexadecimal, no? So these 2 bytes will be 0001. And there will be always 0001 to identify Ethernet, which is the layer 2 technology that we are using. The following field is called protocol type, and it identifies the layer 3 protocol that we are using. So the layer 3 protocol in this case is IPv4, and IPv4 is identified by 0800. So of the 2 bytes, the first byte will be 08, and the second byte will be 00. Okay? Then the next field, which is 1 byte long, is hardware address length. Is the length of the layer 2 address in bytes. So what is the length of a MAC address? How many bytes have a MAC address? 6. So this value will always be 06 in hexadecimal. Then the next field, which is 1 byte long, is called protocol address length. And it will tell us what is the length of the layer 3 addresses, which are the IPv4 addresses in bytes. How many bytes have an IPv4 address? 4 bytes, no? So here we'll have 04, as you can see here. The next field is called operation code. We have two possibilities. It can be an ARP request or it can be an ARP reply. So for an ARP request, the operation code will be 0001. These 2 bytes will be 0001. For an ARP reply, we have another slice to specify that. The operation code will be 0002. And we don't have other possibilities. We only have 2 possibilities. Okay, the next field is 6 byte long. 1, 2, 3, 4, 5, 6. And the name of this field is hardware address of sending station. So that will be the address of the station that send the ARP request. That will be the MAC address of the station that send the ARP request. And the next field is 4 byte long. 1, 2, 3, 4. IP address of the sending station. So as you know, an IP address is 4 byte long. So as you can see, the sending station, the one that is trying to resolve an IP address to a MAC address, put its MAC address and its IP address in the query. What do you think? Why do you think that the sending station, the one that it interrogates, is doing that? Why it's put its MAC address and its IP address in the query? So it's to also give this information to the destination. Because the destination, if I send an ARP request, is because I'm going to have communication with the remote device. So I will need its MAC address, but the remote device to answer me will need my MAC address. So I take advantage of the request that I'm doing to get its MAC address, and I piggyback on the ARP request my MAC address. So it doesn't have to ask me what is my MAC address, because I take advantage that I'm doing a request, and in the request I put that. I put my information, so it doesn't have to ask me my information when it have to communicate with me. And of course, most of the time, a communication between 2 network devices is not one-way communication, it's 2-way communication. So A needs the MAC address of B, and B needs the MAC address of A. So when A try to resolve the IP address of B into a MAC address, A take advantage of the query to piggyback its own MAC address and IP addresses. So B will know the MAC address of A and the IP address of A. It will put it in its ARP cache. Okay, the next field is here, and it's called hardware address of target station, and it's 6 byte long. 1, 2, 3, 4, 5, 6. So this is the MAC address that I need. So in the ARP request, I don't know it. I'm looking for it. So I'm going to fill this field with zeros, saying that I don't know it. So in hexadecimal, it will be 00 for the first byte, 00 for the second byte, 00000000, because I don't know the MAC address of the target station. I want to determine the MAC address of the target station. Now, the last field is 4 byte long, and is the IP address that I want to resolve into a MAC address. Okay? This is for the ARP reply. Let's see the ARP, sorry, it was for the ARP request. Now let's see the ARP reply. As I was telling you, it uses exactly the same PDU, the same field. So it is not a broadcast, a layer 2 broadcast. It is a layer 2 unicast, which means that the station that have to answer will answer with a unicast to the station that was asking for a resolution of an IP address to a MAC address. So hardware type will be again 0001. Protocol type, this identify Ethernet, not the technology of layer 2 that we are using. Prototype identify the layer 3 technology that we are using. We are using IP. And IP is identified by 0800. So that will be 0800. Then, what is the length of a MAC address in byte? A MAC address is 6 bytes, so this will be 06. What is the length of an IP address in byte? Is 4 bytes, so this will be 04. Now, the operation code to say that it's a reply will be 0002 in hexadecimal. So these 2 bytes will be 00 for the first byte, 02 for the second byte. Then we have the hardware address of the sending station of a 6 byte, 4 byte here plus 2 byte here. So this is the MAC address that the sender of the query is looking for. So the station that answered the question put its MAC address here. This is what the station that started the query is looking for. The station that is sending the reply put its IP address here. So IP address of sending station is 4 byte long, 2 byte here, 2 byte here. So that will be the IP address of the sending station. Now, the sender also sent back the MAC address of the destination, no? So I received the MAC address of the destination in the query. I just copy it here. And I copy also the IP address of the target station, which is the destination or the querier here. Okay? Okay, so as I was telling you, when I learn about an entry, which is an entry in the ARP cache, is something that the ARP cache should have at least 2 columns. One column is an IP address, the other column is the MAC associated. Every time that I learn something through ARP with an ARP request, I should, if it is not already in the ARP table, I should add an entry. If it is already in the ARP table, I should refresh the time to live of this entry. So it will stay another 2 minutes. So here they specify the process that a host will follow. So it's when a host creates a packet for a destination, first it's look if the destination is in the same local area network where it is. So if it is in the same local area network, I need the MAC address of the destination. So I check my ARP cache to see if I have an entry for this MAC address. If there is no entry, I will use the ARP protocol to determine the MAC address of the destination. So we will have an exchange, an ARP request, and an ARP reply. Now, if the destination is not in my local area network, I will check my routing table, and the routing table will give me the IP address of the next hop. So if I know the MAC address of the next hop because I have an entry in my ARP table, for that, I am done. I can send the packet to the next hop. If I don't have an entry in my ARP cache, I have to resolve the IP address of the next hop into a MAC address. For that, I'm going to use the ARP protocol. So I will send an ARP request to the default gateway to resolve its IP address into a MAC address. And the default gateway or the next hop will answer with an ARP reply. So with this information, I will be able to add an entry in my ARP cache, and I will be able to communicate with this device. So look at what will be ARP cache or ARP table. We show it with 2 columns, no? But it have more than 2 columns because it have, for example, the time to live. We don't show it here, but if you look at the command that we have here, for example, the Windows operating system keep an entry for 2 minutes in the ARP cache table. Okay, so you can add entry manually in the ARP cache table, or you can remove them also manually. But the ones that are added through the ARP protocol will be removed after some time of inactivity. Normally, well, Windows, for example, keep it for 2 minutes. Okay, so this is a parameter that you can change if you want at the level of the operating system, no? So how do you get the ARP cache? For example, in Windows. In Windows, you open a console or a command or a terminal, and you type the command ARP-A for all. So as you can see, it's an association between an IP address and a MAC. So this IP address is associated with this MAC. This IP address is associated with this MAC. This is what we will see. And in a Cisco router, you can see the ARP cache table with the command show IP ARP. So as you can see, it's also an IP address associated with a MAC address. And we have the time to live, you know. Here, Cisco show the time to live. For example, Windows by default don't show the time to live, but they have a time to live. And at one point, they will disappear. So remember that an ARP request is a broadcast, which means that one device will send an ARP request trying to solve an IP address into a MAC. All the devices in the local area network will receive the ARP request, but only one should answer, because the one that have the IP address that I will try to resolve into a MAC address is the one that will have to answer. Since it's a broadcast, we might have some broadcast storm if we start all the computer of a network at the same time, because they might at the same time try to see if the IP address is already in use. And to do that, they use a small variation of the ARP protocol, which is called the gratuitous. It's a gratuitous ARP request. It's allow them to know if their own IP address is already used by another device, if there is a conflict of IP addresses. So to understand it a little better, let's say that A, that have IP address 10.00.10, want to communicate with B, that have IP address 10.00.20. And we have another device on the network, which is C, with IP address 10.00.30. So A know that B have IP address 10.00.20. So to send a frame to B, A need the MAC address of B. So A look at its ARP cache, and let's say that its ARP cache does not have an entry for 10.00.20. So A will send an ARP request. Since it's a broadcast, it will be received by B and by C. As you can see, it's received by B and by C. So how will be this broadcast? So in layer 2, since it's sent by A and it's a broadcast, the destination MAC is going to be FF:FF 6 times, because this is the broadcast address that we have. Now the source MAC is going to be the MAC address of A, which is 0003478918C6. And the Ether type, which is one field of Ethernet, as I was saying at the beginning, will be 0806. It's a way for Ethernet to say my payload is an ARP PDU. Now this is at the level of layer 2. I should say at the level of layer 2.5, because we will say that ARP is a protocol that arrives up to layer 2.5. We will have some of the field that we showed previously. So the sender MAC address will be the MAC address of A. So A put its MAC address. The sender IP address will be the IP address of A. A put its IP address. Now the target MAC address, this is, A is looking for the MAC address of B. So A doesn't have the MAC address of B at the beginning. So it will fill the target MAC address with 0. And this is the IP address that I want to resolve into a MAC address, which is the IP address of B. So this frame is received by B and is received by C. Let's see what C will do first. So C will see that in layer 2, the network interface card of C will see that the destination MAC address is FF:6 times. So C will say, oh, this is for me because this is for everybody. So C in layer 2 will remove the Ethernet header, and thanks to this field, C will know that in the upper layer, in layer 2.5, you have to give it to ARP. There is a process that runs in C, sorry, because we are talking about C, to receive the request and to answer, to process all the requests of the ARP protocol. So the network interface card of C will pass this query, what is left when it do decapsulation. Decapsulation, it's remove that. It will pass what is left to the ARP protocol that runs in C. So the ARP protocol will say, okay, let me see the question. The question, I want to resolve 10.0020 into a MAC address. So C will say, oh, this is not my IP address. So this question is not for me. I should not answer this question because this question is not for me. So C will drop the query and will not answer because the question is not for C. Now let's see what will happen with the ARP request at the level of B. So the network interface card of B will look at the destination MAC address, which is FF:6 times. So the network interface card will say, oh, this is for everybody because it's the broadcast address, broadcast MAC address. So it will say, okay, I have to process it. So B will look at the ether type to know to whom it has to pass the query in the upper layer, which is layer 2.5, where we have ARP. So this 0806 say pass it to ARP. So B remove the header of Ethernet, which is called decapsulation. And what is left, which is the ARP PDU, B will pass it to ARP that run in layer 2.5. So ARP will say, let me see the query. They want to resolve 10.0020 into a MAC address. So B will say, oh, this is my IP address. So I need to answer this query. So before answering the query, look at what B will say. Since A piggyback its IP address on its MAC address in the query, if B didn't have an entry for this IP address in the ARP cache, B will add it in the ARP cache and will give it 2 minutes of life. So the time to live will be 2 minutes. Then B will answer. So the answer will be what? Remember that the opcode say if it's a query or an answer. Opcode of 0001, it's a query. Opcode of 0002 is an answer or a reply to an ARP request, which means it's an ARP reply. So B will say in sender MAC address, I have to put MAC address, and it will put its MAC address. This is what A is looking for. Then B will say in sender IP address, I'm going to put my IP address. In target MAC address, I will put the MAC address of the device that sent me the request, which is A. So I put the MAC address of A. And in a target IP address, I will put the IP address of A. So this is at the level of ARP. So this will go down the stack and will arrive at the level of layer 2, which is the network interface card. So the network interface card now have to create the Ethernet header. To create it, it needs the destination MAC. I do have the destination MAC of A. Why I have it? Because it was already in my it was already in my ARP table, or I learned it through the ARP request. So I already have the MAC of A. So I will put the MAC of A, I will put my own MAC, and I will say that what is inside the ARP request, what is inside the Ethernet frame is an ARP request. So I will say that the Ether type is 0806. Okay, so we are going to use Wireshark a little more frequently now and get used to Wireshark. Wireshark is a sniffer that allows us to capture the traffic. Wireshark will show you the information that it traffic in different ways. So a way that is a little more easier for us to understand, but it will also show you the frame as a sequence of bytes. So here what I'm showing is for example, the ARP request that A is sending. You want to send it to B, but at the end it sent a broadcast. So this is the ARP request, field by field. So you remember that we have the Ethernet header, the Ethernet payload, and we have the CRC, the cyclic redundancy check. So the Ethernet payload will be the ARP PDU. So first, in the header of Ethernet, I have to put the destination address, which will be the broadcast address. So this blue field is here. Then in source MAC address, I will put my MAC address. I am A. My MAC address is 0003478918C6. So I put it there. Then as the Ether type, I will say that inside Ethernet, we have ARP PDU. The way to say that inside Ethernet we have an ARP PDU is to put for Ether type 0806. Now from here on, we have the ARP PDU. So remember the ARP PDU, we have a group of 4 bytes that identify the layer 2 technology. So these 4 bytes, a group of 2 bytes, sorry. These 2 bytes are here, 0001, and these identify Ethernet. Then we have another 2 bytes that identify the network protocol. It is there, 0800. It means that it's IPv4. Then the next field is hardware address length. It is there. So a MAC address of 6 bytes. Then the next field is protocol address. It is there in green. An IP address of 4 bytes. Then the next field is 2 bytes long. It is there. Is the operation code. So remember, we have 2 possibilities for operation code. When it's an ARP request, it has to be 0001 in hexadecimal. When it's an ARP reply, it has to be 0002. So this is a request, for example, that we are doing. So it have to be 0001. Then the next field is my MAC address. I am A, I'm sending an ARP request. So I'm going to put my MAC address, which is 0003478918C6. So you can see that these 6 bytes that are following is my MAC address. Then the next field is the IP address of the sender over 4 bytes. So it is there, 0A000000A. What IP address is this one?
That is the IP address of A.
It is the IP address of A, but it will be what? So if an IP address is 4 bytes, this is the first byte. What is 0A in decimal?
10.
10. So this is 10.0.0.10, which is the IP address of A. Then the next field, which is here, is the hardware address of target station. This is the MAC address of B. I don't know the MAC address of B. I'm trying to resolve it. I'm trying to resolve it. I'm trying to get the MAC address of B. So I fill this field with zeros, 6 bytes in 0, saying that I don't know it. Then the next field is the IP address of the target station. It's here in yellow. It's 4 bytes long. This is the IP address that I want to resolve into a MAC address. So the first byte is 10.0.0.14. 14 is 16 plus 4 is 20. So this is 10.0.0.20. I am trying to resolve 10.0.0.20 into a MAC address. I need this MAC address. So in green here, we have the CRC. What will be here in purple? What is this field in purple? This is the padding. So if you remember correctly, there is a minimum size for Ethernet. An Ethernet frame cannot be any size. It cannot be as small as I want. It has to be, so the payload have to be at least 46 bytes. So look at the payload start here. Start here. So here we have 2 plus 16 plus 16 plus 12. Here we have 12 bytes. So 2 plus 16 is 18, plus 16 is 34, 34 plus 12 is 46. So as you can see, we have here, we did padding, so we have the minimum that we should have, which is 46 bytes as the payload of Ethernet. So if you take the whole frame Ethernet, it has to be 64 bytes, which is those 46 plus those 2 plus those 6 plus those 6 plus those 4. So 46 plus 2 will be 48. 48 plus 6 will be 54. 54 plus 6 will be 60. And 60 plus 4 will be 64. So the whole Ethernet have to be at least 64 bytes. Or the payload of Ethernet have to be at least 46 bytes. So it's why we do padding. And when we do padding, we just put random bytes. We don't mind if they are in 0 or any other value. Now, let's talk about the ARP reply. The ARP reply is sent by B to A. So B first, at the level of Ethernet, these 6 bytes are here in Siam. So it has to be the destination address. So B is sending that back to A. So it needs the MAC address of A. So B do have the MAC address of A. Why? Because when A sent the ARP request, it did take care of putting its MAC address. So B, if B don't have it, B can learn it with the ARP request. So we are sure that B have the MAC address of A. So let's put the MAC address of A. Then the next field is source MAC address. So this is the MAC address of B. So B put its MAC address here. Then the next type, the next field is ether type. When inside in my payload, I have an ARP PDU, the ether type have to be 0806. Then we start the ARP PDU, which is encapsulated inside Ethernet. So the first field is 2 bytes long, and it's the hardware type. It is there. And this identifies Ethernet. Every time that you want to identify Ethernet, you use 0001. So this is the layer 2 technology. Then the next 2 bytes is protocol type. It is there in yellow. Protocol type, protocol type identify the layer 3 network that we are using. We are using IPv4. on IPv4 is identified by 0800. Then the next byte is hardware address length. So here it's 06 because the MAC addresses have 6 bytes. Then the next byte is protocol address length. Here we have 04 because an IPv4 address have 4 bytes. Then the next byte is operation code. So in a request it will be 0001. That's a reply. In a reply it's 0002. Then we have the MAC address of the sending station. I am B. I am sending that. So I'm going to copy my MAC address here. This is what A is looking for. A is looking for my MAC address. Then in this field, I'm going to put my IP address. I'm the sender. So I'm going to put my IP address. So here in Siam, we have the IP address of the sender, which is 10.0.0.20. Then in hardware address of target station, which is 6 byte long, I'm going to put the MAC address of A. So I know the MAC address of A because I learned it at least in the ARP request. So this MAC address just go there. Then I'm going to put the IP address of A. And the IP address of A is 10.0.0.10. Then I will have the how do you call that? What is the word in English for to say that? The padding. Then you have the padding, no? You have the padding because you have a minimum size. And the minimum size for the Ethernet payload is 46 bytes. So you have to pad with random byte up to 46 bytes. And then you have the CRC in green, which is there. So look at here, this is Ethernet header. It starts here and end here. And here it's Ethernet trailer. It starts here and end here. All that is inside is the ARP PDU. And at the end we have padding because the ARP PDU is so small that it does not complain with the minimum size of the Ethernet payload. So I do have to do padding to comply with the minimum size. Okay, ARP spoofing. So somebody that wants to attack the network might use the MAC address of another device. In this case, we call this ARP spoofing. They are spoofing your MAC address. They are using your MAC address. They are kind of taking your identity. They are using your identity. It's of course, it's a abuse of identity. So we do have some attack on ARP, and it's very easy to spoof the MAC address of another device. No, you can do it by software. Remember that the MAC address is normally stored by the manufacturer in the network interface card. But by software, you can tell the device, don't use the MAC address that is stored or that was burned in the network interface card. Use this MAC address. You can say that by software. And the device will use a different MAC address, not the one that it should use, the one that was assigned by the manufacturer. Okay, we are going to do you have any question about that? So if you don't have question, we are going to go and do some exercises. So I think it might be this one. Yes, it is. Exercise 6. So let's see the first exercise. The following figures show the interconnection between some PCs. Well, we have 4 PCs, no? PC1, PC2, PC3, PC4. We have the IP address, and it's a /24 network. Okay. A network administrator is working on PC4, so it's working there. And realize the capture of 2 frames. So using Wireshark, for example, he captured 2 frames. The first captured frame is shown below. So this is the first frame that the network administrator that is on PC4 did capture. This is a hub, as you can see. A hub always do flooding. Okay, so give all the information about this first frame, including the following data. Who is the sending station? What is the MAC address of the sending station? What is the IP address of the sending station? What is the manufacturer? Is it Dell? Is it IBM? Is it Cisco of the sending PC? What type of frame it is? Is it a layer 2 unicast? Is it a layer 2 multicast? Is it a layer 2 broadcast? What is the frame is intended for, sorry. What value are represented by X here in the frame? What value are represented by Y? Which PC will receive a copy of the frame? And what will the action taken by the PC? So we have this first frame. So to make it easier, I'm going to remove all this, and we will have the graphic and the frame together. So they ask us to give the more information that we can over this frame. So what can you tell me? Let me maybe use my tablets. To do this exercise, so it might be a little easier. So I'm going to redo the frame, and we are going to see the frame in detail. So let me open Paint. Okay, I need this frame. So I need a copy of this frame. I'm going to copy it with snipping tool and put it in there. So let me copy it. Okay, edit copy. And here edit paste. Okay, here is the frame. So help me with that. What is what here? You use the red color. Okay, so according to what we have seen, the first 6 bytes are what? This will be what? The destination MAC address. So that will be the destination MAC address, no? The destination. I'm right with that. It doesn't want to write well. Okay. So the destination MAC address is FF:FF:6 times. What does it mean?
Broadcast.
It's a broadcast. It's a layer 2 broadcast, which means that this frame was sent by one of the PC and it's for all the other PCs because it's a broadcast. So this is the destination MAC address. After that, what we have? We have another field. It will be how many bytes long? This is an Ethernet frame. So we know that on an Ethernet frame, the first field is the destination MAC address. Then what do we have? We have the source MAC address. So the next field will be 6 bytes long. This one, and it will be the source MAC address. So that will be the source MAC address. See if I can do something. Why it's okay, it doesn't help a lot. I'm very sorry for that. So the source MAC address is let me try to write it with my mouse. That will be the source MAC. Okay, the next field is what? How many bytes have the next field? 2 bytes. It belongs also to the Ethernet header. What is that? How do we call this field? The ether type. We call it the ether type. And when the ether type is 0806, what does it mean? This is the ether type.
It means the payload of ARP PDU.
Exactly. It means that the payload is an ARP PDU. So here I'm ending the layer 2 information. I'm ending Ethernet. So I'm going now inside Ethernet. So I know that this is an ARP PDU. I don't know if it's a request or it's a reply at this point. But what is the first field of an ARP PDU? How it's called?
Hardware type.
Exactly, it's the hardware type. So in the hardware type, let me try to get another color. It's 2 bytes long. And when we have a 0001, what does it mean? No, it's
the protocol type.
It's an identifier to tell me what kind of technology I use in layer 2. I'm using Ethernet. So this 0001 say I'm using Ethernet. Okay? It identifies the layer 2 protocol or the layer 2 technology. So it's Ethernet. Okay, what is the next field? How many bytes it has? The next field has 2 bytes, and it is called what?
Protocol type.
Protocol type, exactly. So this identified the layer 3 protocol. It identified what? IPv4. So this tells me that we are using, in layer 3, we are using IPv4. In layer 2, we are using Ethernet. So we are using IPv4. What is the next field? The length of the layer 2 addresses. It's 1 byte long. So this field in green say that the MAC addresses or the layer 2 addresses have 6 bytes. What is the next field? Let me put it in yellow. It have 1 byte, the next field. It have this 4. And this 4 identify what? It say that in layer 3, where we have IP, the addresses, which are IPv4 addresses, are 4 bytes. You know that the IPv4 addresses are 4 bytes. So what is the next field? It have 2 bytes, and it's called what? Operation code. You have the slides, no? Let me show you the slides. The next field is called the operation code. Fortunately, I cannot show everything here. Okay, so we are here. We are in the operation code. So the operation code can be 0001 or 0002. When it's 0001, what can I say? So this blue is operation code. Let me try to put it here. OP for operation code. When it's 0001, it means what?
This is an ARP request.
It's an ARP request, of course, because it's a broadcast. Remember that an ARP request is a broadcast. An ARP reply is a unicast. So this is an ARP request. Okay, so what will be the next field? How many bytes it have? 6 bytes. This is the sender MAC address. Of course, look, it's exactly the same. The sender MAC address in layer 2 is the same as the sender MAC address in layer 2.5, which is okay. So this is the MAC address of the device that is sending this ARP request. We still don't know who sent the ARP request. Now, what is the next field? Let me put it in purple. The next field is what? 4 bytes, correct. And it is what? The sender IP address. So this is the sender IP address. Source IP address, no? Sender IP address. Let me try to write here sender. You see the difficult that you don't come to class. These don't want to work today. Cannot do it walking. Let me see if I have a tool here. It will help me. I think the driver are not installed in this computer. Well, no way. This is the sender IP address. Sender IP address. So we know who is sending that. Who is sending that? Which device? What is this IP address? 10.0.0.5. So who is sending that? PC2. PC2 is trying to resolve an IP address into a MAC address. So PC2 is the sender of this ARP request. If you want to communicate with another device. So what is the next field? It's a field of 6 bytes. And this is the target MAC address. This is the MAC address that I want to resolve. I don't know it. So since I don't know it, I put it in 0 in the query, no? Where is the PowerPoint slide? So here we are here. We are the hardware address of target station. I don't know it. I don't know the MAC address. Is why I send the ARP request. So what is the next field? The IP address that I want to resolve. 4 bytes. So what is this IP address? 10.0.0. what? So C is 12. 12 times 16 is what? 192. 192. 192 plus 8 is 200. So this is 10.0.0.200. So this is the IP address of which device? Of PC3. So PC2 is trying to get the MAC address of PC3. So the X, what are the X? Padding. What are the Y? The CRC. This is the CRC. Okay, so this is cyclic redundancy check. And the X are the padding. So I did answer the question.
Wait, so which one you said was the target MAC address that we didn't know? What part are we in?
It is there. The target MAC address is there. 00000000000000.
What part of the PBU are we?
This is the ARP PDU, and it is there. Hardware address of target station. So let me see. These 6 bytes are those 6 bytes. Then the source MAC address are those 6 bytes. Then the header type are those 2 bytes. Inside we have that. It is encapsulated. So these first 2 bytes are 0001. Then these 2 bytes 0800 are protocol type. Then we have a field of 1 byte, which is hardware address length, the MAC address of 6 bytes. Then we have the protocol address length, the network address, which are IP address of 4 bytes. Then we have the operation code over 2 bytes. 0001 is an ARP request. 0002 is an ARP reply. Then we have over 6 bytes. 1, 2, 3, 4, 5, 6. We have the hardware address of standing station. It is there. So this is, at the end, we know that it's the MAC of 10.0.05, which is the MAC of PC2. So PC2 is the sender. This is the MAC address of PC2. Okay? This is the IP address of PC2. Here, I want the MAC address of PC3. I don't have it. So I fill it with 0000. And here we are talking about hardware address of target station. 1, 2, 3, 4, 5, 6 bytes. And finally, we have the IP address of target station over 4 bytes. So this 4 bytes in yellow is the IP address of the that I want to resolve into a MAC address. So it's the IP address of PC3, because I want to resolve the IP address of PC3 into a MAC address. Okay, this is the IP address of PC3 because the IP address of PC3 is 10.0.0.200. This is 10.0.0.200. Then we have padding. How many bytes of padding we have? 18 bytes of padding. And then we have the CRC. Okay, so if you look, it's exactly what we just saw here. We have 18 bytes of padding, then we have 4 bytes of CRC. So this frame is exactly the same as this one, but it's another example. Is it okay? So they ask us, what is the manufacturer of the sender? Which means which company build this network device, this PC? How can I know? So the MAC address gives me information about the manufacturer. So the MAC address of the sending station is D8-9EF3. So what should I do? I go to IEEE that manage the MAC address, and I ask IEEE about this organizational unique identifier. So let me put it in Google. Let me show IEEE organizational unique identifier. So it is there. So you see, this organizational unique identifier is for this company. This one is for this company. This one is for this company. So the one that I'm searching, remember that the organizational unique identifier is the first 3 bytes. I'm looking for D8-9E-F3. So let me search in this web page. D8-9E-F3. Okay, I found it. DA9EF3. Dell Inc. Which means that this is a Dell computer. Okay? A Dell computer is sending an ARP request saying that he wants to resolve 10.0.0.200 into a MAC address because he needs the MAC address of PC3. Okay, let's see question 2. Question should say, the second capture, because it was 2 frames that were captured, the second capture is shown below. Give the information about the second frame, including the following data. Okay, we have this second capture. What can we say about the second capture? Let me make a copy of it also here, so we can write on top of it. Okay, here is the second frame. So what can we say about the second frame? So the first 6 bytes will be what? The destination MAC address, exactly. So here we have the destination MAC address. Do we already know this MAC address? Yes, this is the MAC address of who? of PC2. So this is the MAC address of PC2. This is the destination. Destination MAC, DST MAC. And this is the MAC of PC2. As you know, we already know the MAC of PC2. So this frame is a unicast. And it goes toward PC2. We already know that. Okay. The next 6 bytes, what are there? Those bytes. Yeah, is the source MAC. Okay, so this is the source MAC. Source MAC. Okay, what is the next field? To byte, and it is what? Is the header type. When the header type is 0806, it's mean what? Inside Ethernet, we have an ARP PDU. So if inside Ethernet we have ARP PDU, we are in this case inside Ethernet. Here we have this, because here we can have other things. But if here, these 2 bytes said 0806, they say that inside I have that. So if inside, here we start the inside. We have that. The first 2 bytes are the hardware type. So this is the hardware type. This is an ARP. This is an ARP. This is an ARP PDU. So we have the hardware type. This hardware type identify what? The hardware type, no? Which is Ethernet. We say that in layer 2 we are using Ethernet. That's fine. This network is Ethernet. So thanks to God, this network is Ethernet. So thanks to God, it say we are using Ethernet. Then the next field say what? The next field that say in layer 3 we are using IPv4. So it's easy to see, because if you look at the IP address, there are IPv4 addresses. So here it say in layer 3 the protocol that we are using is IPv4. It's not IPv6. Then the next field is this field. What is the length of the MAC addresses? 6 bytes. So this 06 say that the MAC addresses have 6 bytes. Then the next field is protocol address length. What is the length of the IP addresses or layer 3 addresses? 4 bytes. Then the next field is operation code. So this field that is coming, let me put it in purple, is operation code. When we are talking about ARP PDU, we have 2 possible values of operation code. 0001 will be an ARP request, and 0002 will be an ARP reply. So 0002, what is that? An ARP reply. And as you can see, it's a unicast. Here we don't have a broadcast address. So this is an ARP reply. We already know. ARP reply. We already know that it's go toward PC2. They are sending into PC2. So what is the next field? The next field has 6 bytes long. It's hardware address of sending station. Okay, this 4 bytes on this line plus this 2 bytes. So it has 6 bytes long. So 1, 2, 3, 4, 5, 6. It's end here. So this is the MAC of the sending station. This is the MAC of the station that is sending the ARP reply. Okay, what is the next field? The IP address of the sending station. So who is the sending station? Or what is the IP address of the sending station? So 0A is what? 10. 0, is 0. So it's 10.0 dot. We have another 0. So dot 0. And the last one is C8. C8 is 200. So this is 10.0.0.200. So this is the sending station. Who is the sending station? PC3. So PC3 is sending to PC2. We already know that. It's an ARP reply. Okay, what is the next field? It has to be the MAC address of PC2 because PC2 is sending that. It has to be the MAC, no, it has to be the MAC address of PC2 because PC2 is the target station. Okay, so this is the MAC address of PC2. So the next field will be the IP address of the destination. Who is the destination? PC2. So these have to be the IP address of PC2, 10.0.0.5. It is PC2 have 10.0.0.5. All the X are padding, all the Y are CRC. So what can I say after that? So that was ARP send an ARP request, trying to resolve 10.0.0.200 into a MAC address. And PC3 answer with an ARP reply. So it provides to PC2 its MAC address. So now PC2 have the MAC address of PC3 and PC3 have the MAC address of PC2. They can communicate to each other. And remember, this is the MAC address of PC2 and this is the MAC address of PC3. Okay? So after this exercise, after capturing some traffic, we know what is the MAC address of both of them. Okay, I hope I can fix this this pen for next time. I think it's driver installation. I don't have the admin password in this computer, and this is very frustrating. Okay, let's finish today here because we don't have enough time to do an exercise, and we continue on Tuesday. So I see you on Tuesday, okay?
Professor, I thought we were taking Tuesday off for the CMA conference.
I do take the class that is before, but this one, because in the security class we go very well. We don't have a lot of topic that is left. Unfortunately, here we do have a lot of topic that is left. So we cannot take the class of Tuesday for the conference. So we will have classes, but before you can attend the conference, okay?